Hi everyone, welcome back to Mind and Maths. Today we are going to study rational expectations, which is one of the most important ideas in modern macroeconomics. The key idea is very simple. It is that people in the economy are not guessing blindly. They form expectations using all available information, including economic theory and policy rules. Because of that, the economy behaves differently compared to models with adaptive expectations. So, in this lesson, I'll explain the intuition clearly and then we'll derive the reduced form step by step. And inshallah, by the end, you will see why only unexpected policy can affect output and why announced policy becomes ineffective. In this model, I have the aggregate demand equation, which is given, and an aggregate supply policy curve given by this, and the expected value of the error terms is equals to 0, while the expected price today is the price which is expected um, uh, one period behind. Okay, so first of all, we basically are aiming to find the reduced form of y. So a reduced form is that you uh, present uh, the endogenous variable in terms of all exogenous variables. So for instance, if I find the reduced form equation of y, it cannot depend on p because p is also an endogenous variable. So if yt and pt are endogenous variables, then if I want to find the reduced form equation of y, then it can not be a function of pt, because the reduced form, I'll repeat this again, is an endogenous variable being represented by all exogenous variables and parameters. Okay, so let's begin. I'll try to make this easy by creating steps. So for instance, step 1 is that we can express pt from aggregate supply. So where was aggregate supply? This was our aggregate supply curve. Let's make pt the subject. This is fairly easy. Let's just open it up. I'll be left with, maybe I shouldn't skip any steps and I should actually write this down. I'll have a yt minus vt, and this again right here. I have this weird temptation to skip steps, but when I'm teaching, I shouldn't do that. So here we are, divide through by theta. And now it's easy to make this the subject, right? Because I'm going to just bring this to the right side and I'm going to bring this to the left side. So I'll have pt in terms of yt. So pt is equals to m bar plus psi yt minus 1 minus yt minus vt over a theta. Okay, now I need to take expect, because in this equation I have pt, which I just found, but I also need the expected value of pt, right? So let's make that into the next step, so there's no clutter in our brain. Okay, so take the expected value of pt to find this. Okay, let's start. This was the equation that we just found. So I'm just going to copy it down over here. And I'm going to take the expected value. So the expectations of PT at time t minus 1, a constant remains a constant no matter what. So this remains the same. And yt minus 1 is in the same time period, so it remains the same. Then we have the expected value of yt minus 1 at yt at t minus 1 over a theta, and expected value of vt as our assumption is equals to 0, so that just disappears. Therefore, the expected price at time t is just this expression here. So what expression was in the aggregate demand curve? It was actually PT minus PET. So we had to subtract this from this expression. Let's do it. Okay. Here we go. So you can see very nicely the M cancels out with the M. So money supply this disappears. And this cancels out as well. Okay, so we're left with minus yt over a theta plus vt over a theta minus expectation of yt at time t minus 1 over a theta. And therefore we can write this as minus yt minus, oh sorry, I think if this becomes, when I open the bracket, it becomes a plus. I hate it when I make these mistakes. Okay, thank God I caught it right now, because otherwise the error would have just like would have had ripple down effects, which are, I feel, forgivable. Okay, so we have this expression, and this is what we needed. So we can make a step 3. So our step 3 is to put the expression that we just found for the price difference in the aggregate demand. So writing down the aggregate demand equation once again, this was the aggregate demand equation, and now I have to basically put the value that I found over here. So let's do that. I have a delta yt minus 1 plus, actually now this will become a minus beta over theta, and we have a yt minus the expected value of yt in the previous time period, and then we'll have a plus vt over a theta, and I guess this is gonna get multiplied by a beta as well. So yeah, so we should have a beta here as well, plus ut. Okay, now what? I think we should open this up. Let's open this up. Delta yt minus 1, because I can take this over there. Yeah, so let's open it. So when this goes over there, I'll get a 1 plus, or let's just keep it open right now. I'm just gonna do it like this. yt by t, and this becomes a plus beta over theta, expected value of yt at the previous time period plus this again. So I just basically just opened up the bracket. Okay, so step 4. Step 4, take the expectation of yt at previous time period of above equation. The reason why I'm doing this is that I don't want this expression over here, because I want yt in terms of yt minus 1, because that will give me the reduced form. So let's start putting the expected sign. This was my equation, yt. So expected value of yt at time t minus 1 is, this is at the previous time, so this is the actual, the expected is equals to the actual, so this remains here, and constant go outside, and expected value just comes on the variable. Then expectation of an expectation is just, it's just an expectation, so this remains the same. This already had an expected sign, and then we have a 0 plus a 0. As you can see, this cancels out, and then we're left with that the expected value of yt at time t minus 1 is delta yt minus 1, and we're happy here because now this thing can disappear from my equation. So we have the final answer. Let's just call it step 5. Solve for yt. Solve for the reduced form equation of yt. And let's do that. This was our main equation. Let's copy and paste. And now I'm gonna get rid of this expression right here. So I'm gonna substitute it in. Okay. When I substitute it in, I'm also gonna take this on the other side. So I'll be left with 1 plus beta over theta into a yt. And then I have a delta yt minus 1 plus beta over theta into delta yt minus 1. I replace this that we found, and then we have beta over theta vt plus ut. Okay, so far so good. Now we can take yt minus 1 as common, and this becomes theta plus beta over theta into yt, and then we have a delta plus beta. We can take the LCM. Yeah. Oh, there was actually a delta here as well. Delta. So why not take the delta outside then? Delta can go outside. Then we can get a theta plus beta over theta. Okay, I hope I didn't mess this up. And then the errors continue to come down. And actually this nicely kind of like it cancels out. Kind of looks nice. So yt is equals to this whole expression divided by this. And so we're left with delta y t minus 1 plus, okay, theta and theta will get cancelled. So I'll be left with theta over theta plus theta, okay, vt. And over here I'll be left with this goes up and this goes down, ut. Oh, and over here we had actually this had a beta, okay, sorry, beta, and theta gets cancelled, so we just have beta over this. Okay, good enough. If there's a mistake, I'll fix it. Okay, so so this is actually the reduced form equation. So the reduced form equation, now we have yt in terms of all exogenous variables. So we can write it like this. And now we can also see how, what the why their output deviates from the expected. We can actually also find the reduced form equation. Maybe I should add that as well in this, just in case. Let's just add a step 6, finding the reduced form equation for price t. I'm just adding this as a just in case extra step. What was pt? Let's, oh, here it is. So this was our pt, and now we know the value of yt. So let's substitute it in. This is gonna take some time actually, because yt minus 1 over theta into y, oh, this whole expression. Oh, it's gonna take some time. And a plus vt over a theta. Should I solve it or not? I think it's gonna take some time, but you get the picture. It's already like this yt minus 1's already happened, so it's exogenous, and all of these variables are also exogenous. So this is like, even if I don't simplify it because I'm feeling lazy, this still is the reduced form of our equation. So actually we don't need to, like, I'll just join these, like I'll just put this together and then not simplify it further. So I can write it like this and then not bother to solve more. So I can just write this down here, and then just, this kind of looks slightly better. Anyhow, so this is, we found the reduced form of y and p. And the one final thing that we should be concerned about is the variance in output. So variance of output. Remember that the error terms are actually uncorrelated. So if and the variance of a constant is 0. So for instance, I'll write the formula down. If I have a variance of x plus y, then it's simply going to be the variance of x plus the variance of y, if and only if the covariance of x and y is equals to a 0. That means that they're uncorrelated. Okay, so and remember, the variance of any constant is 0, because a constant, it's not varying, right? It's just, it's stable, it's straight, so there's no variance. Okay, so coming back to the reduced form equation of output, it was this, and we are interested in the variance uh, of the output. So variance of yt is going to be yt minus 1 is known. So sorry, I accidentally spoke Urdu. The variance of yt minus 1 would be a 0. And I struggle a lot with speaking only English because I'm actually not, my mother tongue is not English, so you'll have to bear with me. Oh, another rule that I forgot to mention over here is that if it was a variance of a constant and a variable, then the constant is squared and you get the variance of the variable. Okay, so by that, I'm going to get the square of the constant and then the variance of ut, and then the square of this constant and the variance of vt. So you can write it like this: the variance of yt is equals to, the variance of this constant square and the variance of, I think this was u, and the variance of v. Okay, so just remember as a final conclusion, which can be like a one line takeaway, that under rational expectations, only unanticipated shocks, these unanticipated, sorry, I wanted to hide, unanticipated shocks move output. So if I draw a sketch, suppose this is the long run level of output, then any kind of deviation that we have from a y bar will actually be due to just the shock terms, so which are unanticipated. So the deviations are due to ut and vt, which are basically, these are unanticipated. We have time on the horizontal axis and we have output on the vertical axis, and that brings about the end of this model. As a recap, the important takeaway is that when people use the model itself to form expectations, the government cannot systematically influence real output using predictable policy. Output only changes when there is a shock surprise. when there are shock surprises. If you found this helpful, please leave a comment and let me know which topic you would want next. And see you next time. Take care.